Hello, we are here for one more lesson of this T-FLEX analysis training course, continuing in the forced oscillations, and today we will see about something we call special features of this forced oscillations analysis. We have again the same example as in the previous lesson, just to give you an idea of one specific model we can calculate with this kind of analysis. But speaking a little about these special features, so as all the other type of analysis, this is carried out in several stages. This is basically the same as the other type of analysis, but we have only certain aspects which are characteristic of this forced oscillation analysis. So the first thing it is when we go, and again to the analysis menu, we create a new study. So the first specific thing about these forced oscillations, it is we need to choose a specific type of study, which is this one, forced oscillations. Then the thing that we call the boundary conditions, so imposing boundary condition in this type of analysis, as also in static analysis, constraints and loads play the role of boundary conditions. This is not the same for other type of analysis that we've seen in this video course, but in this specific type of analysis, these again constraints and the loads are in fact the boundary conditions, and they are mandatory to execute properly the analysis that you want to run. Then the analysis execution. So before the execution of the analysis, the user specifies the properties, the values for frequencies, which you know already we have around here. Okay, we have a lot of things to specify. Okay, in this particular case we don't create a new type of analysis, so I'm not sure, or at least 100% sure of the things we have here. But we need to specify all the conditions that we have for the analysis, and after solved, which I'm not sure if we have results in this particular, no, we don't have. We can run a study. Let us try to run one without going through the parameters. But again, after running the study, the stage which is getting and analyzing the results, these specific analyses include amplitudes, displacements, oscillation accelerations, oscillation overloads, phases of oscillations. So it's very specific stuff that regards this type of analysis. So we can also view or we have a capability of viewing the deformed state of the structure in various stages. So this one in particular, I'm not sure what we will get, but we can try to animate this, okay? And we have something called the deformed state. So let us try to see something. And basically, strain state, we can see a lot of things about this. So we could update extremist positions, okay. And we have several things we can see with these results. So this is what we have for these special features of this forced oscillation analysis. Any help, any additional information you might need, so you know what to reach us already, so send us your contacts.